Hello and welcome. Today we're going to learn how to achieve an man-in-the-middle attack through Python coding. We are going to implement it through raw socket, which is our major part of that course. So in part number 1 we are going to discuss how to implement and to understand the R poisoning on our LAN devices targets, which we are going to implement it through a simple method. In part number 2, we are going to implement this attack on our gateway for both sides, which meaning that our attacker machine going to forward our packets from the client to the gateway and from the gateway to the client when we talk about secure gateways, which most of the time will block our ARP poisoning. In part number 3, we are going to interface with the netfilter queue to our netfilter queue and implement more advanced techniques to enable our ARP poisoning. So, in part number 1, after we are going to poison our devices in our LAN, we are going to sniff the specific data we search in SMTP, HTTP, FTP and ICMP protocols. So let's begin. As we can see, we have a simple architecture, LAN architecture. As you can see, we have 4 devices. Okay, we have the client, we have our attacker, which is called Babylon Sec, we have our server, which have inside it SMTP and FTP services, and our gateway. The first attack that we will implement is between the client and the server. What I mean when I say between? When I say between, this is exactly the meaning of the man-in-the-middle attack. The attacker computer will be between the client and the server and will be in charge to forward the packets between the client and the server without that both devices will notice. So, how the ARP work and why it's so important? As we know, in our LAN, most of our communication will be based on MAC addresses. Each client, each server have inside the MAC table, which is going to guide him and to say to him which IP addresses have its corresponding MAC addresses in order to send to the right target. So, or receive. So, when the client or when the server is asked in ARP request, in broadcast, when it was broadcast to all the LAN, who is behind those specific IP addresses, the specific clients which have those specific IP addresses will answer with their physical, with their MAC addresses, and that's how they will know each other. So let's take a look. Let's connect to our client. Okay, let's delete our ARP cache and see how it's working. So let's delete our cache, just a moment. Okay, we delete our cache and now let's see how our R table will build. So our client first send a broadcast, okay, which you can see it over here on the destination, and of course with the address with double F, which meaning broadcast to all the segment the device is available on. So we are sending an ARP request, okay, which its opcode is 1, and we send a request which says, hey, I wish to know who is behind this IP address who have the corresponding MAC address. So the device who has inside him the specific IP address we ask will reply with opcode number 2 to the same client who sent the specific request, right? So we can see that we will accept the reply with the MAC and its corresponding IP address. With the answer that the IP address 114 will be the device which have the 114 have this specific MAC address, and that's how our client is going to talk to each other. First, they will validate the corresponding MAC address to the IP addresses they have they wish to talk to. They cannot talk direct to the IP address. We are not in layer 3. We are in the same segment without VLANs. We are in layer 2. So, as you can see, in this entry level in layer 2, we can change a little bit the details and make a simple attack which will in seconds direct all the packets to our side and not to the server. So what we need to do is as follow. We need to change the MAC address to our attacker MAC address and to save the same IP address, okay? So we are going to send a reply to our client without even he ask our request. We're going to say, hey, the 114 IP address, which is the server IP address, now I am 114 with my MAC address, which is in this example going to be 6 times 333. So as the client will accept it, as we saw over here, it will update its ARP table, okay, without any problem, and will accept it, and it will be legal without any problem. So it's very important to know how layer 2 really works, because there is a lot of issues and insecure environment which make our segment, our devices exposed to attacks. So we need to know how to defend our segment. So let's take a look. Let's run our script. Let's run our script and we'll see how we are going to change without any problem the IP addresses, the MAC address of our client MAC table. So let's run the script and let's again ask the ARP table, and we can see I didn't run the, okay, we can see the difference, okay, on the gateway, but it's not the right script. I need to send the second script. Okay, now we'll see that our server have different okay. now we can see that our server 114 have just a moment. So let's take example how our server MAC address is going to change in our client MAC table. So we know that our gateway MAC address is going to change in our client MAC table. So we know that our gateway is on that specific MAC address. So let's change it with our script, which is going to do simple task, which basically is going to send an ARP reply, which is going to say that 1.1 is on that specific MAC address. So you can see how easily with layer 2 to redirect the packets, the data from one to each other, and it's very, very dangerous. This layer is exposed to different kind of attacks. So we can see that we send with our attacker computer that specific reply, which says as follow, that 1.1 is on that specific MAC address, and we are going to send it to our client, which is on this specific MAC address. We can see it additional over here. Okay, to whom this packet will go, it will mention in the destination section in the Ethernet header, okay, before the ARP header. So it's very important. In the ARP section, you can see that how it's easy to change the things. So let's stop our script and see again in our presentation how the things looks. So we are going to use our token computer and send ARP reply to our client and an ARP reply to our server, which will say, as you can see at the ARP table on both devices, that 192.168.112, which is the client IP address, is going to be on the attacker MAC address, and as well the client with its MAC table, which says that 1.14, which is the server, will be on the MAC address of our attacker computer. So what is the next thing to do after we got successfully the attack that we implement with the ARP reply? We will need to ensure that the forwarding, if it's Linux computer in our case, to enable it, and to ensure that we are controlling the packets between those two devices. So before it, let's see how to construct the packet. So let's enter to our packet, to our socket, and see how we implement it. So the first thing we did is to create a socket which says PF packet, which is basically means we are working in the most low level of our layers, which is layer 2. Then of course we are using our socket, and the third one is you can write, or you can even ignore it, which says socket.htone, which is available for all. You can remove it, it will not make any difference. The next thing, which we know, it's the frame header, because we are using the PF packet, so we need first to construct the frame header, so of the internet. So how it look like? Very simple. We have source MAC address, we have destination MAC address, which basically says to who and from this information, this data is coming and going to. and the protocol. The protocol in that case would be 0806, which means ARP. Okay, we're going to use the ARP protocol and not the IP. So the next section is going to be the ARP protocol header. So we have as follow: the hardware type, which is going to be 1, okay, the protocol type, which is going to be IP 0800, the length of the hardware address, which is 6 bytes. We can see it over here: 1, 2, 3, 4, 5, 6 bytes, and the length of our IP address, which is 4 bytes. So we can see that is 1, 2, 3, 4 bytes. And then the opcode, which is going to be 2, which basically means reply, and the opcode 1 means request. So we need to use the reply in order to make our attack available. So the next thing is to construct the same packet to the same frame, the same ARP packet to our client. So in the first at the first packet, first frame, the ARP packet we construct, it was for our server, okay, which mentioned that we're going, the destination MAC, as you can see over here, is for our server, and that specific MAC address is our attacker computer. And then again we are going to say, hey, 192.168.1.12 is going to be on the attacker MAC address, and we are going to send it to our client, to our server. So we're going to send it to 192.168.1.14. So we are going to tell him that 112 is on the attacker MAC address. Now we need to do the same for our client, to tell him that 192.168.14 is on the MAC address of the attacker, and we're going to send it to our client, to 112. So let's see again our presentation. We can see that we're going to send an ARP reply to our client and ARP reply to our server. And then the next step is to enable forward to our machine, which is the attacker machine. So let's look on our IP tables. So we can see that we are going to forward only from 112 to Google. So let's say that we wish to send it to our server. So let's do it for both sides, okay, in order to make it forward available to both sides. Okay, so let's do a simple test. Okay, let's run our program. now we are going to send a ping request to our server, which is already, as you can see on the ARP table, is going to forward it to our attacker computer. So let's see. Okay, we have reply. So let's capture some SMTP packets and learn how if the forwarding is really works, and if we have if the both ways are really communicate with each other through our attacker computer. So let's stop with the ping and see what we succeed to capture. So let's start with the first ping. As we can see, the first 6 bytes is the destination. So it's meaning that we are going to send this SMTP ping to our server, which is, after we attack, you can see that it's not the server MAC address, it's the attacker MAC address. And the source is the client, as we can see over here. So we got the first ping. And then we can see that our attacker send it to our server, forward it to our server, right? We can see still it's a request by the 0800, right? It's not a reply. And then the server, right? Sorry. The server will reply to our attacker a reply ping, where we can see it over here with the 00. So we will reply for the same sequence number of the SMTP protocol, right? Which we can see over here. Sorry, which is the 16. Sorry, which is the 685A. This is the sequence number. So after we have our sequence number, and we have the reply, the attacker computer needs to send it to our client back to make sure it get its reply, so it can ping and it can get a reliable result as follow, right? You will get this result just after we'll get the reply. So you can see on the fourth packet, the attacker computer will send to the client the reply, which we can see is the same sequence number, and that's how we are going to finish with the forwarding and successfully forward between those two devices. So we can see that to each ping, okay, we are going to be charged and forward the request. So our attack is working great, and also our forward is working. So let's validate another protocols, but before let's see how the attack is working. So we can see that we can see that we have interval of 25 seconds for each packet we sent, and we don't have any problem. Okay, so let's see again. We can see that 114 is on the MAC address of the attacker, and we send it every 25 seconds. We can see it over here. 80244 and 80219. So it's 25 seconds. So each 25 seconds we send our reply to our client, and we don't have yet any problem. The real problem that you will have if you wish to attack, as you can see over here, that if I have any open connection with the client, we are the server, don't forget, yes? We are the 114. So, sorry for that. So, when we are working with RDP on other services that already open with the client, we are always will send back to the client that we are 114. So, in order to avoid it, in part number 2, I will show you how you first disconnect the connection between those pairs of devices and reconnect them again through the attacker computer, and then you will not have any problem, as you can see. But right now we don't have any problem, we don't feel any problem. If we will ask again the ARP, you can see that 114 is still on 31 on the attacker computer, and we just pay attention that we send each 25 seconds the reply that the poisoning up. So it's very big interval, and we don't flood our network. Okay, so it's very we can see efficient. So let's concentrate how to sniff the packets between those two devices when we are forwarding. We enable the forwarding between those two devices. So let's continue. So let's begin sniff some packets between our client or server. So as we know, our server, which is a relay on the IP address 192.168.114, have inside him SMTP server and FTP server. So let's test our sniffing and see the result. So over here, yes, we are running the right program. We are sending an ARP reply to the server and to the client, which says as follow: the attacker address, MAC address, would be the corresponding IP address for each side. So let's see it again. We can see again that we are the attacker, okay, with our MAC address. We are going to send to the server MAC address as follow: an opcode of ARP reply, which going to say, hey, I am with the following MAC address. This is my IP, which is in the end 12, which represent the client, and I'm sending it to the server, which is rely on 192.168.114 on the following MAC address. And as the same, we are going to do to the client. Hey, I am the attacker. This is my MAC address. Okay. here it is your MAC address of the client. I am going to send an ARP reply which have the following. The following MAC address is rely on the following IP address. So the IP address of 192.168.1.14 have the following MAC address, which is the MAC address of the attacker, and the IP address is the IP address of the server. So that's how we are going to redirect all the packets between the client and the server through the attacker computer. So let's run it, and let's run our sniffing program, which is going to sniff our FTP, HTTP, and SMTP. Let's start with SMTP. Okay, so we have here, as you can see, an Outlook program which is connect to our server, which is rely on 192.168.1.14, which right now we can see that is going to redirect the packet through the attacker computer. So let's open our Outlook. Okay, which is the Thunderbird. So we can see that the connection working fine. Now let's send an email, and we wish to get from that email only the username and the password, right? If we are interested in more details, we can take the data, the subject, and other things that there is in SMTP connection. So let's send an email, okay, for the client, and we will see what we can capture for our sniffer. Let's send it. Okay, as you can see, we got the login of the SMTP client to the server details. So we got that the username in base 64 we decoded its copy, and the password of the email as well in base 64 we decoded to the following, which is says the password in regular string is Babylon. The remote IP which we sniff from that client, which is going to make the connection to with the SMTP connection, is to 192.168.1.14. Now let's test an FTP connection. Okay, so as we can see, let's remember my login. Let's start from beginning. Okay, so the FTP protocol asks from credentials, so let's test. Okay, the credential is not correct, so let's now put. Okay, we have right now the correct credentials, and we are inside the FTP server, which we can see all the files that he accepted to share with us. Now let's see what we successfully to sniff. At the first time which we arrived to the FTP and click enter, we can see that it tried to make login with anonymous, and it's just an example. And then we can see at the second time we entered with the correct credentials, which was already saved. And at the third time, when we try with invalid login, you can see over here the password and the username. And at the last time, which our credentials was correct, we can see the following username and password. Now let's try some HTTP. Let's take test login. Okay, let's take something from outside. Okay, so let's write Babylon sec and password babsec1. Click enter and let's see if we got something. No, we didn't got something because we forgot to add an IP tables rule that says that we can accept the connections. So we forgot to add an role to our IP tables, and I suggest you to define all the rules that you need before you implement the ARP poisoning. So let's see what we have missing. So let's first flush our and accept in the policy everything. Now it's look good. So before you poisoning your devices, please consider your architecture, or you shouldn't consider your architecture, and just enable the forwarding policy at your IP tables. So let's see right now some HTTP connection, if we can sniff. So let's try again. Oh, okay. So, as we can see, we additional got HTTP data. We successfully sniff the username and password. Additional, we have we got the remote IP of the connection. So let's try again the SMTP and FTP and see that everything is working fine after we change the rules of the IP tables forwarding. Right. So as we can see, we can sniff the protocols we search and we wish to take from them data. As you notice, we have just one direction for our gateway, meaning that our attacker machine will forward just the packets from the client to the gateway and not the opposite way. Okay, the client will get the response from the gateway directly. So as you can see over here, we have just between the client to the gateway just one direction. So let's see an example for that. Let's ping to Okay, let's see what we can learn from that. So what do we see over here? Okay, we took out the ICMP sniffing we did with our attacker machine, and we can understand a couple things. The first thing that we can understand, that the client is forwarding through our attacker machine, or more correctly to say, our client try to send an ICMP request, and our attacker machine will forward it to the gateway, but we don't see any connection from the gateway to the client, meaning we are not forwarding through our attacker machine the ICMP replies from the gateway to the client. It's gonna be directly from the gateway to the client. So how we can know it? We can know it by the following sniffing. Okay, as we can see, we enable the sniffing on our attacker machine, which is going to forward any packet that is waiting to be forwarding. So we can see that if any packets from the gateway were needed to be forwarded to the client, we should see it in our sniffing result. So what do we see over here? First thing, as you can see, I put the correct MAC addresses for each device. Okay, so you can understand more the following sniffing ICMP packets. So the first 6 bytes, okay, in our sniffing data is the destination address, the MAC destination address, which is our attacker machine MAC address. The second address is the source, the next 6 bytes, the source MAC address, which is the client computer, our client, which is asked to ping to 4 times 8. Okay, you can see it over here. Sorry. We can see it over here. You try to ping to 4 times 8 and it will be a request. So the first thing that we see is that our client is asked to ping, and now it's up to the server to forward this packet. So what do we see in the next packet, the ICMP packet? We can see clearly that our attacker machine will forward it to our gateway. So as we spoke, the first 6 bytes is the destination MAC address, which is the gateway. Okay, as you can see, and the next following 6 bytes is our attacker machine, which is forwarding this ICMP request. You can see again that we ask ICMP request to 4 times 8. So it's meaning that our attacker machine will forward this packet, okay, to our gateway, and we don't see any reply from the gateway through our attacker machine. It means that we just poisoning in one direction the client and the gateway. So the client will get back directly the ICMP replies, if we will have reply, from the gateway. So let's dive into our sniffer and see how we could capture our HTTP, FTP and SMTP data. So what we did is really simple sniffer. We create a socket which will sniff from the layer 2, from the AF packet. Next we define row socket, which we are going to use, and the third configuration is not necessary. You can leave it without it. Then we define endless while loop, which will iterate and find if there are any ICMP packets. If so, it will print it. It's not matter. You can notice by the protocol we try and we ask to sniff. It's not matter the direction. It's matter just if there are any ICMP requests, we will sniff and print it. We didn't mention any address, just the protocol on our IP header, which 01 is reference to ICMP, and its location on 2324 if we are using AF packet. Next, we are willing to sniff the data that is transferred from the client to the server. So first we mention that our source MAC address is the client, okay, which is 6 to 12. We ask it from the Ethernet frame. Next, we define on our IP on IP header protocol the digit 06, which reference to the TCP protocol. If there are any requests from this MAC address and the following TCP protocol, please do the follow. If it's gonna be HTTP, meaning 50 in X, and it's gonna be from our client, please open a new text file and write down all the packets you are success to catch. Then we will iterate into the text and find if we have any username or password. If so, we are gonna print the username and password and the remote IP address of our connection. Next, if we didn't, next if condition, if we didn't success to catch any HTTP, please, if you see or if you sniff any SMTP protocol, SMTP connection, which is 19 in X, and the source MAC address of that connection is our client, please open an SMTP text and write down the packets I success to sniff. Next, we are going to create an index into our text in order just to print out the username and password of our SMTP connection, and the next thing is to decode our username and password, which is gonna be in base 64. Next condition: if we didn't catch any HTTP or SMTP, if you see in your sniffing data that the source MAC address is the client and the protocol of the connection is FTP is 15, so do the following. Open an FTP text, write down the sniffing packets you successfully to catch, and then just print the username and password to our screen. And that's how we're gonna to iterate again and again and again. Don't forget that our first if is if the source is our MAC address and the destination and the connection is gonna be TCP, based on TCP protocol. Okay, all of those connections we saw: the HTTP service, the SMTP service, and the FTP service. So that's all for part 1. In part 2, we are going to concentrate how to manage to do this attack in our gateway for both directions. Is more specific for secure gateways. And in part 3, we are going to make advanced technique of R poisoning, and we are going to interface with our net filter queue. So thank you very much for watching this video. Bye bye.